Now in this lecture we will find out the value of angle x. In the drawing we have triangle PQR. We know that QS equals to SR. We also know that angle PSQ equals to 45 degrees. Angle PQR equals to 3x. Angle PRQ equals to x, and we want to find out the value of angle x. So first of all, we will define angle PQPS. This angle is angle alpha, and we will also define angle SPR as beta, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees, and so if we focus on the straight line QR at point S, on the upper side of the straight line QR, the sum of the angles at point S must be equal to 180 degrees. So here we have at point S we have 45 degrees, and we define this angle as angle X, and according to the rule that I mentioned, 45 degrees plus angle X must be equal to 180 degrees. So here we will subtract 45 degrees from this equation, and we will get that angle X equals to 180 degrees minus 45 degrees, it equals to 135 degrees. So found out that angle X is, actually it is not the angle that we are looking for, angle X, but this angle is equals to 135 degrees. Okay, actually I should call it angle Y in order not to be confused with the angle X that we are looking for. Okay, anyway, this angle is angle PSR equals to 135 degrees. So in the next step, I will present to you a new rule. It calls the rule is the law of sines. The law of sines apply in any triangle. So you can write down that in any triangle if we have triangle, this triangle, and we know that the length of this side is A, it equals to A units, and in front of side A we have angle A, and we also know that the length of this side is B, and in front of this angle, or in the opposite sides, we have angle B, and the length of this side is C, and in front of this side we have angle C. So according to the law of sines, A over sinus A equals to B over sinus B, and it equals to C over sinus C. That is the law of sines that is applied in any triangle. From this equation we will derive that A over sinus A equals to B over sinus B, we will cross multiply this equation and we will get that A over B equals to sinus A over sinus B. We got the equation that states that A over B equals to sinus A over sinus B. What does it mean? It means that the ratio between the lengths of a triangle is equal to the ratio between the opposite angles, because angle A is in the opposite sides of side A, and angle B is the opposite sides in relation to side B. So we can write down that the ratio between the side lengths of a triangle is equal to the ratio of the opposite angles, so of the ratio between the opposite angles. So I read again the rule that says that the ratio between the side lengths of a triangle is equal to the ratio between the opposite angles. So actually, if we focus on our drawing, we know that here PS over QS is equal to PS over SR. Okay? Actually, PS over QS equals to PS over SR because of the fact that QS equals to SR. So QS equals to SR. And according to what I mentioned, we know that PS over QS will be equal to sinus 3x over sinus alpha. And it equals to PS over SR. If you focus on triangle PSR, we get that PS over SR equals to sinus X over sinus beta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So actually, if you focus on triangle PQR, we will get that alpha plus 3x plus 45 degrees must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 3x and also 45 degrees from this equation number 2, and we will get that angle alpha equals to 180 degrees minus 3x plus 45 degrees. So we actually express the value of angle alpha in terms of x. In the next step, we will focus on triangle PSR, this triangle, in triangle PSR, the sum of the angles in triangle PSR is equal to beta plus 135 degrees plus x, and the sum of those three angles must be equal to 180 degrees. I will repeat again. The sum of the angles in triangle PSR is equal to 180 degrees, that is to say beta plus 125 degrees plus x must be equal to 180 degrees. Here we will subtract 125 degrees and also x from this equation number 2, and we will get that angle beta is equal to 45 degrees minus x. So we expressed angle alpha and also angle beta in terms of x. So now we can substitute sinus alpha and sinus beta in equation number 1 by the values that we found out for sinus alpha and sinus beta. So we'll do it now, and we will get that according to equation number 1, sinus 3x over sinus alpha, and we have already found out that alpha equals to 180 degrees minus 3x plus 45 degrees, so we substitute alpha by 180 degrees minus 3x plus 45 degrees, and it equals, according to equation number 1, it equals to sinus x over sinus beta, but we have already found out that beta equals to 45 degrees minus x, so we will substitute beta in this equation, equation number 1, by 45 degrees minus x, and we also have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. We will use this trigonometric identity in order to simplify equation number 1. So we will get that here, according to equation number 1, sinus 3x over here we have sinus 180 degrees minus 3x plus 45 degrees. According to this trigonometric identity, it equals to sinus 3x plus 45 degrees, so I write it down. And it equals to sinus x over sinus 45 degrees minus x. So here we will first multiply this equation number 1, and we will get that according to equation number 1, sinus 3x times sinus 45 degrees minus x equals to sinus x times sinus 3x plus 45 degrees. Here we will multiply equation number 1 by 2, and we will get that, according to equation number 1, 2 times sine 3x sine 45 degrees minus x equals to 2 times sine x sine 3x plus 45 degrees. So here we will use the trigonometric identity that states that 2 times sine A sine B equals to cosine A minus B minus cosine A plus B. So we use this trigonometric identity in order to simplify our equation number 1, and we will get that here actually A is equals to 3x and B equals to 45 degrees minus x. So 2 sine 3x sine 45 degrees minus x, according to this trigonometric identity, will be equal to cosine A minus B, but A is 3x and B is 45 degrees minus x. So 3x minus minus x is 4x. Minus 45 degrees minus cosine A plus B, that is to say minus cosine A is 3x and B is 45 degrees minus x. So 3x minus 3x is 2x plus 45 degrees we finished with the first part of equation number 1. Now we will go to the second part. So here x will be equal, A equals to x and B equals to 3x plus 45 degrees. So 2 sine x sine 3x plus 45 degrees, it equals to cosine A minus B. Cosine A minus B is cosine A is x and B is 3x plus 45 degrees. So x minus 3x is minus 2x, and it is actually minus 45 degrees. Okay. And we have also minus cosine A plus B. A is x, B is 3x plus 45 degrees, so x plus 3x is 4x plus 45 degrees. So here we will add to this equation number 1, cosine 4x plus 45 degrees, and also cosine 2x plus 45 degrees. But before that, we have here cosine minus 2x plus 45 degrees, and according to the trigonometric identity that states that cosine minus x equals to cosine x, we will we can turn cosine minus 2x plus 45 degrees to cosine 2x plus 45 degrees, because of the fact that cosine minus x equals to cosine x. Okay, so we will add to this equation number 1, cosine 4x plus 45 degrees, and also cosine 2x plus 45 degrees. And we will get that, according to equation number 1, cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 times cosine 2x plus 45 degrees. So we found out that according to equation number 1, cosine 4x plus 45 degrees plus cosine 4x cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 times cosine 2x plus 45 degrees. So here we will use the trigonometric identity that states that cosine C plus cosine D equals to 2 times cosine C plus D over 2 times cosine C minus D over 2. Okay. And we also, for the other side of equation number 1, we will use the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A times sine B. So we will use those two trigonometric identities in order to simplify our equation number 1. And we will get that according to equation number 1, this side of equation number 1, cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, according to this trigonometric identity, will be equal to 2 cosine. First of all, here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So we will get that cosine 45 degrees minus cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 cosine c plus d over 2, 2 cosine c plus d is c is 4x minus 45 degrees and d is 4x plus 45 degrees. So we have cosine c plus d. So 4x plus 4x is 8x and 8x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. And then we have also cosine c minus d. C is 4x minus 45 degrees and d is 4x plus 45 degrees. So c minus d, 4x minus 4x is 0. And minus 45 degrees is 90 minus 90 degrees, and minus 90 degrees is minus 45 degrees. But according to the rule that cosine minus x is equal to cosine x, we will get that cosine minus 45 degrees equals to cosine 45 degrees. So I write down cosine 45 degrees, and it equals to 2 cosine 2x plus 45 degrees. Here a equals to 2x and b equals to 45 degrees. So cosine 2 cosine 2x plus 45 degrees, according to this trigonometric identity, will be equal to cosine a, and a is 2x, so it is cosine 2x times cosine b. B is 45 degrees, so it is cosine 45 degrees minus sinus 2x times sinus 45 degrees. We know that sinus 45 degrees is equal to cosine 45 degrees equals to sine 45 degrees. So we actually can divide this equation number 1, by 2 cosine 45 degrees. Again, sine 45 degrees equals to cosine 45 degrees. So we got here that cosine 4x equals to cosine 2x minus sine 2x. Okay, we got this equation. Here we will add to this equation sinus 2x and we will subtract cosine 4x, and we will get that according to equation number 1, sinus 2x equals to cosine 2x minus cosine 4x. That according to equation number 1, sinus 2x equals to cosine 2x minus cosine 4x. We know that according to the trigonometric identity that sine 2x is equals to 2 sine x cosine x, and here we have cosine 2x minus cosine 4x, and we have the trigonometric identity that states that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. So we will use this trigonometric identity in order to find out the value of cosine 2x minus cosine 4x. Here C equals to 2x, C equals to 2x, and D equals to 4x. And cosine C minus cosine D equals to 2 sine D plus C over 2, that is to say it equals to 2 sine D is 2x, C is 2x, D is 4x. So it is C plus D is 2x over 4x, and over 2 is 3x. 6x over 2 is 3x, and we have to multiply it by sine D minus C over 2. So here we have D is 4x and C is 2x. So D minus C is 4x minus 2x. 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we found out that 2 sine x cosine x equals to 2 sine 3x times sine x. Here we will divide this equation number 1, by 2 sine x, and we will get that cosine x equals to sine 3x we have the trigonometric identity that states that cosine alpha equals to sine 90 minus alpha. We use this trigonometric identity, and according to this trigonometric identity, cosine x equals to sine 90 minus x. So sine 90 minus x, according to equation number 1, equals to sine 3x. So here we can write down that 90 minus x equals to 3x. Okay, we got the equation that states that 90 minus x equals to x. We will add x to this equation, and we will get that 90 degrees equals to 4x. here we will divide by 4 this equation, and we will get that x equals to 22.5 units. So we found out that according to the first method, that the value of x is actually 22.5 degrees. Okay, I'll repeat, the value of x according to the first method is 22.5 degrees. We finished with the first method. In the next step, I will present to you how to find out the size of angle x, or the value of angle x, according to the second method. Okay? And in the second method, we will define angle PQPS as alpha, as we did in the first method. And we also define angle SPR as beta. We know that it is given us in the question that this angle is 45 degrees. And because of the fact that this angle is 45 degrees, I will not repeat on the things that I did on the first method. This angle must be equal to 135 degrees. Okay, we already found out that in the first method that this angle PS R equals to 145 degrees. And here we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, if we focus on triangle PQS, according to, we have already did it on the first method, so I will did it shortly. In triangle PQS, according to the first method, we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. I'll repeat again. In triangle PQS, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract 45 degrees from this equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So according to equation number 1, alpha plus 3x equals to 135 degrees. We will focus on triangle PSR. In triangle PSR, the sum of the angles must be also equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. So according to equation number 2, beta plus 135 degrees plus x equals to 180 degrees. We will subtract 135 degrees and also x from this equation number 2, and we will get that beta equals to, we will subtract only 135 degrees from this equation, and we will get that beta plus x equals to 180 degrees minus 135 degrees, it equals to 45 degrees. Here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 135 degrees. Okay, so we can write down that equation number 1 equals to equation number 2 because of the fact that in the right side it equals to, in both equations, it equals to 135 degrees. So we can write down that equation number 1 equals to equation number 2. That is to say, this will be equation number 3. Alpha plus 3x, that equals to 135 degrees, must be equal to 3 beta plus 3x, according to equation number 2, that is also equals to 135 degrees. So here we will subtract 3x from this equation, equation number 3, and we will get that alpha equals to 3 beta. We found out that alpha equals to 3 beta according to equation number 3. Okay, according to equation number 3, alpha equals to 3 beta. Okay, now we'll do a construction from point Q. We'll draw a straight line to PR, to side PR of triangle PQR in such a way that we will get angle X. And we will define the touching point between the straight line to side PR as point M. So we drew the straight line QM in such a way that angle MQR will be equal to X. And because of the fact it is given us in the question that angle PQR equals to 3x. So if this angle equals to x, then this angle must be equal to 2x because in total they are equal to 3x. Okay? So here triangle QMR is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to x. And because of the fact that the isosceles triangle QMR has two angles here that are equal to x, it means that the base of the isosceles triangle MQR is QR. The base is QR. It is given us in the question that QS equals to SR. So MS, we will join together points M and S together by a straight line. MS is the median to the base of isosceles triangle QMS. Why MS is the median? Because of the fact that it bisects the base QR into two equal parts. That is to say QS equals to SR according to what is given us in the question. But we have rule number 3 that I have already mentioned in the previous lectures, that the median to the base in an isosceles triangle is perpendicular to the base. So the median MS not only bisects the base QR into two equal parts, but it is also perpendicular to the base. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And we have a new rule. According to the new rule, the exterior angle of a triangle is equal to the sum of the angles that are not adjacent to the exterior angle. So, what is the meaning of the rule that I stated? It means that if we have triangle ABC, this is angle alpha, this is angle beta. Angle OAB. This angle is defined as the exterior angle of triangle ABC. According to the rule that I mentioned, the exterior angle OAB equals to the sum of the angles that are not adjacent to this exterior angle. This angle BAC, is adjacent to the exterior angle OAB. Okay? The only two angles that are not adjacent to the exterior angle OAB are alpha and beta. And according to the rule that I mentioned, the value of the exterior angle OAB is the sum of the angles that are not adjacent to the exterior angle. That is to say, it equals to alpha plus beta. The exterior angle OAB equals to alpha plus beta. So, according to this rule, if you focus on the isosceles triangle QMS, and we also focus on this angle, it is exterior angle of the isosceles triangle QMR. And the value of this angle is the sum of the angles that are not adjacent to this angle. And the two angles that are not adjacent to this exterior angle are x plus x, that is to say, the value of this angle is x plus x, that is to say, it equals to 2x. Okay? So, as you can see, triangle PQM is an isosceles triangle because of the fact that it has two angles that are equal to each other. Both those two angles are equal to 2x. Therefore, triangle PQM is an isosceles triangle. What does it mean that triangle PQM is an isosceles triangle? According to the rule that in front of equal angles there are equal sides, so in front of these angles that are equal to each other we have equal sides. That is to say, PQ equals to PM. PQ equals to PM. So you can write down that PQ equals to PM. because of the fact that in an isosceles triangle, the sides that are in front of the equal angles, they are also equal to each other. Okay, it means that PQ equals to QM. In the next step, we will do a construction from point P. We will draw perpendicular to QM, and we will extend the perpendicular until it touches side QS. So first of all, this is perpendicular to QM, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees, and we will define the touching point between the perpendicular to QS as N. We will define the touching point between the perpendicular from point P to QM as L. And we will focus on triangles PQL and PML. Triangle PQL and triangle PLM. Okay, in those two triangles, those two angles, they are equal. So angle PQL equals to angle PML and both those two angles, they are equal to 2x. We just right now draw perpendicular to QM, so those two angles, they are right angles, they are equal to each other. So angle PLQ equals to angle PLM. Equals to 90 degrees. I repeat again, angle PLQ equals to angle PLM equals to 90 degrees. So we have here two pairs of angles that are equal in those two triangles. In those two triangles, we have two pairs of angles that are equal. Those are the first pair, and those are the second pairs of angles that are equal to each other. Therefore, according to third angle theorem, those two angles, they are also equal to each other. That is to say, angle QPL, this angle, must be equal to angle MPL, this angle, and to angle MPL, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay, but why? Because it is complementary to 180 degrees. I have already explained it in the previous lectures, so I will not repeat on it. So those two angles are equal to each other. It means that, what does it mean? It means that if this angle is theta, then this angle must be also equal to theta, because those two angles are equal to each other. So angle OPL equals to angle PL equals to theta. You can see here, from the drawing, you can see it easily. That theta plus theta equals to alpha plus beta. It is clearly, you can see from the picture, from the drawing, that theta plus theta equals to alpha plus beta. Okay, theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and it equals to alpha plus beta. But in the beginning of the second method, we got equation number 3 that states that alpha equals to 3 beta. Found out that alpha equals to 3 beta, so we can substitute alpha in equation number 1 by 3 beta. We will do it now and we will get that 2 theta equals to alpha is 3 beta plus beta. 3 beta plus beta is 4 beta, so we got that 2 theta equals to 4 beta. We will divide equation number 1 by 2 and we will get the theta, angle theta equals to 2 beta. Angle theta equals to 2 beta. You can write here angle theta equals to 2 beta. So here, this is angle theta, yes? All this angle is angle theta. And we see that this is angle beta. We have already found out, we just right now found out that angle theta equals to 2 times beta. So if this angle is beta, then this angle must be also equal to beta because of the fact that beta plus beta must be equal to theta. So this angle must be equal also to beta. Angle A NPS must be equal to beta because of the fact that angle NPM equals to theta and theta equals to 2 beta. So if this angle is beta, this angle must be equal to theta in order to get to the equation that 2 beta equals to theta. Okay? So in the next step, we will prove, first of all, we just found out that angle MSQ is a right angle because of the fact that the median MS is perpendicular to the base of the isosceles triangle QR. The median MS is perpendicular to the base QR of the isosceles triangle MQR. So angle MSQ is equal to 90 degrees. But it is given us in the question that this angle is equal to 45 degrees. So this angle must be also equal to 45 degrees in order to complete the sum of those two angles to 90 degrees, because we know that this angle is a right angle. Okay? So this angle equals to 45 degrees in order to complete the sum of the angles here to 90 degrees. This angle is 90 degrees, this angle is 90 degrees, so 45 degrees plus 45 degrees equals to 90 degrees. Okay, otherwise we will not get that the sum of those two angles are 90 degrees. So those two angles must be equal each 45 degrees. So in the next step we will prove that triangle PNS is perpendicular to triangle SMP. I'll repeat again. We will prove that triangle NPS, triangle NPS is congruent to triangle PSM, this triangle, PMS. So we'll prove that those two triangles can go into each other. So why those two triangles can go into each other? First of all, those two angles, they are both equal to beta, therefore they are equal to each other. So we can write down that angle NPS in triangle NPS equals to angle MPS in triangle MPS, and both angles they are equal to beta, therefore they are equal to each other. So again, angle NPS equals to angle MPS equals to beta. PS is a common side, it belongs to both triangles, so we can write down that PS equals to itself. PS equals to PS. PS equals to itself. It's a common side that belongs to both triangles. I will repeat again. Side PS equals to itself because it is a common side that belongs to both triangles, and those two angles, they are equal to each other, they are both equal to 45 degrees. So we can write down that angle NSP equals to angle MSP, and they are both equal to 45 degrees. Again, repeat again. Angle NSP equals to angle MSP equals to 45 degrees. So we actually found out that those two triangles can go into each other according to angle side angle rule. I'll write it down. We found out that triangle NPS congruent to triangle PMS according to the rule, according to angle side angle rule. So what is angle side angle rule? According to angle side angle rule, if two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. And we found out that those two angles in the side that included, that is to say PS, in triangle PNS, can go into those two angles, and the side that included, that is to say PS, in triangle PSM. Therefore, we prove that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that MS equals to SN. 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 So I will draw we join together points M and N by straight line, and I will draw the right triangle, triangle M and S. The right triangle, triangle M and S. So you can see this is MS is the median to the isosceles triangle, triangle MQR is the median to the base. Therefore, this angle is a right angle. This angle is a right angle, and because of the fact that MS is equal to NS, what does it mean? It means that in front of equal sides there are equal angles. It means that this angle must be equal to this angle. If we define this angle as y, then this angle will be also equal to y. So y plus y, that is 2y, must be equal to 90 degrees. Why? Because we have here 90 degrees, so the sum of the angles is 180 degrees. So what is left from the rest of the angles is 90 degrees. So 2y equals to 90 degrees. We will divide the equation, this equation by 2, and we will get that y equals to 45 degrees. So we found out that this angle equals to 45 degrees, and this angle also equals to 45 degrees. Angle MNS equals to 45 degrees. Angle MNS equals to 45 degrees. And also angle NMS equals to 45 degrees. Okay. So in the next step we will focus on triangles. First of all, I will draw the quadrilateral P, Q, and M. I will draw the quadrilateral P, Q, and M. And we will prove the triangle PQN We prove the triangle PQN the green triangle PQN is congruent to the white triangle PNM. We will prove that those two triangles congruent to each other. We know that PQ equals to PM. We have already found out that PQ equals to PM. So PQ in the green triangle equals to PM in the white triangle. We have already found out that this angle is 2 beta. This angle equals to theta, that is 2 beta. And this angle is also 2 beta, beta plus beta. Angle theta equals to 2 beta. So we can write down that angle QPM equals to angle NPM. And both angles are equal to beta, to 2 beta. We found out that both angles are equal to 2 beta. And we also have a common side. Pn is a common side. So Pn equals to Pn as a common side that belongs to both triangles. Pn equals to Pn as a common side that belongs to both triangles. So we actually proved that the green triangle PQN, is congruent to the white triangle PNM, according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between those two sides in one triangle congruent to two sides and the angle between them in another triangle, then you proved that those two triangles congruent to each other according to side angle side rule. So actually the green triangle PQN, congruent, this is the sign of congruent, to triangle, the white triangle PNM, according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that Qn equals to Nm. Qn equals to Nm. So I will write it. I'll write it here. Qn equals to Nm. Okay? According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides Qn and M will be also equal to each other. So Qn equals to Nm. If we join together points Q and M by a straight line, you can see here QM, we have QM. This angle NQM equals to X. Angle NQM equals to X. But because of the fact that Qn equals to Nm, according to the rule that in front of equal sides in the triangle there are equal angles, what does it mean? It means that if this angle is x, this angle must be also equal to x. Okay? And here we have Qn and then we have S. So if we focus on triangle QMN, on this triangle that is half green, on triangle QMN, so you can see here angle MNS equals to 45 degrees. We have already found out that angle MNS equals to 45 degrees. But according to the rule that the value of the exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it, it means that this angle MNS, will be equal to x plus x. That is to say, it will be equal to 2x. So we found out that angle MNS equals to 2x. So angle MNS equals to 2x, and it also equals to 45 degrees. It means that 2x equals to 45 degrees, and we divide this equation by 2, and we will get that angle x equals to 45 degrees over 2, it equals to 22.5 degrees. So we found out that according to the second method, the value of angle x is actually 22.5 degrees. Okay? So now I'll summarize the lecture. Actually, we wanted to find out the value of this angle x, in triangle QPR. We have here triangle PQR. We know that angle PSQ equals to 45 degrees, angle PQR equals to 3x, angle PRQ equals to x. So if this angle is 45 degrees, then this angle must be equal to 135 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR at point S, the sum of the angles must be equal to 180 degrees. That is to say 45 degrees plus this angle, that is angle X, angle X or Y or whatever, must be equal to 180 degrees. So we'll subtract 45 degrees from this equation, and we will get that angle X equals to 135 degrees. Then, according to the law of sines, in any triangle, if the length of this side is B, the length of this side is C, and the length of this side of the triangle is A, then A over sinus A equals to B over sinus B equals to C over sinus C. This is the law of sines that is true in any triangle. So from this equation, we will derive that A over sinus A equals to B over sinus B. We will cross multiply this equation and we'll get that A over B equals to sinus A over sinus B. What does it mean? It means that the ratio between the sides of the triangle is equal to the ratio between the opposite angles. Okay? The ratio between the sides, the side lengths of a triangle is equal to the ratio between the opposite angles. Okay? So if we focus on our triangle, on our drawing, in our drawing we have here, we also know that here QS equals to SR, I forgot to mention it, but here we know that PS over QS will be equal to PS over QR, PS over SR, because of the fact that QS equals to SR. I repeat again, PS over QS must be equal to PS over SR, because it is given us in the question that QS equals to SR. Okay, but according to the law of sines, what we actually derived from the law of sines, PS over QS in triangle PQS, what's the value of PS over QS in this triangle? PS over QS equals to, here we have PS over QS. PS over QS must be equal to sinus 3x over sinus alpha, according to the rule that I mentioned. PS over QS equals to sinus 3x over sinus alpha, and PS over SR, if we focus on this triangle, PS over SR must be equal to sinus x over sinus beta, according to the rule that I mentioned. PS over SR equals to sinus x over sinus beta. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQR, the sum of its angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 3x and 45 degrees from this equation number 2, and we will get that alpha equals to 180 degrees minus 3x plus 45 degrees. Then we will focus on triangle PSR. On triangle PSR, the sum of the angles must be also equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. Triangle PSR, beta plus 135 degrees plus x must be equal to 180 degrees. We subtracted 135 degrees and x from this equation number 3, and we got that angle beta equals to 45 degrees minus x, because 180 degrees minus 145 degrees is 45 degrees, and we also subtracted x, so we got that angle beta equals to 45 degrees minus x according to equation number 3, and according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees. So here we actually substituted alpha and beta by the values that we found for alpha and beta in equation number 2 and 3. We substituted alpha by 180 degrees minus 3x plus 45 degrees from equation number 2, and we substituted beta by 45 degrees minus x from equation number 3. And we got this equation, and according to the trigonometric identity, the sinus 180 degrees minus theta equals to sinus theta, we will get that here sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x minus 45 degrees. So, in conclusion, we got that sinus 3x over sinus 3x plus 45 degrees equals to sinus x over sinus 3x minus sinus 45 degrees minus x, because multiply this equation number 1, we got this expression, we multiply this expression by 2, and we got this expression, and we used the trigonometric identity that states that 2 sine A times sine B equals to cosine A minus B times minus cosine A plus B. Okay, and here in our specific equation, we know that A equals to 3x and B equals to 45 degrees minus x, and therefore 2 sine 3x sine 45 degrees minus x will be equal to cosine A minus B. A is 3x and B is 45 degrees minus x, so 3x minus x is 4x, and it is also minus 45 degrees. So in conclusion, we got here cosinus 4x minus 45 degrees, and it's also minus cosine A plus B. Minus cosine A is 3x, B is 45 degrees minus x, so A plus B is 3x plus x is 4x. No, it is actually 3x plus minus x. And 3x plus minus x is 3x minus x. 3x minus x is 2x plus 45 degrees. So, in this side of the equation, we got this expression. We finished with this side of equation number 1. Then we did the other side of equation number 1. Here 2 sine x times sine 3x plus 45 degrees. Here we know that A equals to x and B equals to 3x plus 45 degrees. And we get that it equals to cosine A minus B. Cosine A is x, B is 3x plus 45 degrees. A minus B is x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So we got here that it equals to cosine minus 2x plus 45 degrees. So we have minus here before the brackets. But because of the fact that we know that cosine minus x equals to cosine x, we can turn the minus to plus, because cosine x equals to cosine minus x equals to cosine x. So we can turn the minus to plus. So we did it, and we got cosine 2x plus 45 degrees. And it is also here minus cosine A plus B. A is x and B is 3x plus 45 degrees. A plus B is x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. So we got here minus cosine 4x plus 45 degrees. Okay, so here we added cosine 4x plus 45 degrees to this equation, and we added cosine 4x plus 45 degrees, and here we add minus cosine 2x plus 45 degrees, so we added also minus cosine 2x plus 45 degrees, and we have here also cosine 2x plus 45 degrees. Cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees is 2 times cosine 2x plus 45 degrees. So in conclusion, we got that cosine 4x minus 45 degrees equals to cosine 4x plus 45 degrees equals to 2 times cosine 2x plus 45 degrees. Here we simplified this expression by the trigonometric identity that states that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And this expression, it is actually cosine a plus b, and cosine a plus b equals to, according to this trigonometric identity, it equals to cosine a times cosine b minus sine a times sine b. Here d equals to 4x plus 45 degrees here, and c equals to 4x minus 45 degrees, and d equals to 4x plus 45 degrees. So here cosine c plus cosine d equals to 2 times cosine c plus d over 2, 2 times cosine c plus d. C is 4x minus 45 degrees and d is 4x plus 45 degrees. So c plus d, 4x plus 4x is 8x, and 8x over 2 is 4x. And the minus 45 degrees plus 45 degrees is 0. So in conclusion, we got here 2 times cosine 4x, and we also have here cosine c minus d over 2. C minus d. C is 4x minus 45 degrees, and d is 4x plus 45 degrees. 4x it is actually c minus d, so it is 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But because of the fact that minus 45 degrees, cosinus minus 45 degrees equals to cosinus 45 degrees, we change the cosine minus 45 degrees to cosine 45 degrees. And here we have actually cosine, it is cosine a plus b. And cosine a plus b, a is 2x and b is 45 degrees. And cosine a plus b, according to this trigonometric identity, equals to cosine a times cosine b. That is to say, it is cosine a is 2x, so it is cosine 2x, and b is 45 degrees, so it is cosine 45 degrees, minus sine a times sinus b. Sine a is sine 2x, and sine b is sine 45 degrees. So here, we actually divided this equation number 1, by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled. 2 cosine 45 degrees will get cancelled, and we know that sine 45 degrees equals to cosine 45 degrees, so we can cancel sine 45 degrees and also 2. So in conclusion, we got that after we divided this equation by 2 cosine 45 degrees, we got that cosine 4x equals to cosine x minus cosine 2x. Okay, then we added sinus 2x to this equation, and we got that sine 2x equals to cosine 2x minus cosine 4x. And we know that sine 2x equals to 2 sine x cosine x, and it equals to cosine c minus cosine d, according to this trigonometric identity, equals to 2 sine d d plus c over 2 times sine d minus c over 2. C is 2x and d is 4x. So sine d plus c over 2 is actually 2x plus 4x is 6x, and 6x over 2 is 3x. So it is 2 sine 3x. And here we also d minus c over 2. D is 4x, c is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So we got here sinus x. In conclusion, we got that 2 sine x cosine x equals to 2 sine 3x sine x. We divided this equation number 1, by 2 sine x, and we got that here cosine x equals to sine 3x. And you can also ask yourself why it is allowable to divide the equation by sine x. Maybe sine x is 0. And if sine x is 0, you are not allowed to divide the equation by 0. But according to the drawing, sine x can never be 0, because if sine x would have been 0, then angle x will be 180 degrees or 0 degrees. You can see clearly here that angle x is not equal to 180 degrees and not to 0 degrees. So sine x, according to this drawing, can never be 0. It can never be 0 because it is not equal to, x is not equal to 0 degrees and not to 180 degrees. But it is also something between those two numbers. So sine x can never be 0. That is the reason that it is allowable to divide the equation by sine x, because sine x can never be 0. Okay, and then so we got that cosine x equals to sine 3x, and we have the trigonometric identity that sine 90 minus x, that cosine x equals to sine, we have cosine alpha equals to sine 90 degrees minus alpha. Therefore cosine x, according to this trigonometric identity, will be equal to sine 90 degrees minus x, and it equals to sine 3x. So we can, from this equality, we can derive that 90 minus x equals to 3x. We added x to this equation, and we got that 90 equals to 4x. And we divided this equation by 4, and we got that x equals to 22.5 degrees. So the value of angle x is 22.5 degrees. Then I presented to you how to find out the value of angle x according to the second method. In the second method, we actually defined angle Q A S as alpha, angle S P R as beta, and here we know that this angle equals to 45 degrees, therefore this angle must be equal to 135 degrees according to what we did in the first method. And then actually we in triangle PQS, we know that the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 45 degrees and x from this equation, and we got that we subtracted only 45 degrees from this equation, equation number 1, and we got that alpha plus 3x equals to 135 degrees, and in triangle PSR, the sum of the angles must be equal to 180 degrees. in this triangle, that is to say here beta plus 145 degrees plus x must be equal to 180 degrees. We subtracted 145 degrees from this equation and we got that beta plus x equals to 45 degrees. We multiplied by 3 this equation number 2, and we got that 3 beta plus 3x equals to 135 degrees. So here we can compare equation number 1 to equation number 2, and we get, according to the statement, that 135 degrees equals to 135 degrees. That is to say, alpha plus 3x equals to 3 beta plus 3x. We subtract the 3x from this equation number 3, and we got that alpha equals to 3 beta. So according to equation number 3, alpha equals to 3 beta. Then we made a construction from point Q. We draw a straight line to side PR in such a way that this angle will be equal to x, that is to say angle MQR will be equal to x. And we join points M and S together by a straight line. Those two angles, they are equal to each other, they are both equal to x, that is to say, it means that triangle QMS is an isosceles triangle. And the base of the isosceles triangle QMS is QR. We join point M and S together by a straight line. MS is the median to the base of the isosceles triangle QMR, and the median to the base, according to rule number 3, not only bisects the base, but is also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So we know that those two angles are equal to x. And this is the exterior angle of triangle QMR, the isosceles triangle QMR. And we know that the value of the exterior angle is equal to the sum of the angles that are not adjacent to this angle. The two angles that are not adjacent to this exterior angle are x plus and x. So this angle will be equal to x plus x, that is to say it equals to 2x. And according to the rule that the exterior angle OAB of triangle ABC equals to the sum of the angles that are not adjacent to this exterior angle, and the two angles that are not adjacent to this exterior angle are alpha and beta. That is to say, this angle, the exterior angle, equals to alpha plus beta. So according to this rule, we got that this angle equals to 2x. So here, those two angles, they are both equal to 2x. Therefore, triangle PQM is an isosceles triangle. It means that PQ equals to PM, because in front of equal angles, there are equal sides. That is to say, PQ must be equal to PM. And then we draw perpendicular to QM from point P, and the perpendicular, so we define this point as point N, and we define this point as point N. So in triangle PLQ and triangle PLM, we have two angles that are equal. Those two angles, they are both 2x, and those two angles, they are right angles. Therefore, those two angles must be equal to each other according to third angle theorem. Okay? Again, in triangle PQL and PLM, we have angle PLN equals to angle PML equals to 2x. Those two angles, they are equal to each other, they are both equal to 2x. Angle PLQ equals to angle PLM equals to 90 degrees, those two angles. And angle QPL must be equal to angle MPL. According to third angle theorem, those two angles must be equal to each other because they are complementary to 180 degrees according to Third-angle theorem. Okay, angle QPL equals to angle MPL equals to theta according to Third-angle theorem. And if we define this angle as theta, then this angle must be also equal to theta. Okay? Then, so we know that PQ equals to PM, and here we proved that triangle PQL. So, okay, here according to Third-angle theorem, those two angles are equal to each other, and if this angle is theta, then this angle must be also equal to theta. And from the drawing you can see that theta plus theta equals to alpha plus beta. Again, theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. That is to say 2 theta equals to alpha plus beta. But according to equation number 3, alpha equals to 3 beta. So according to equation number 1, theta equals to alpha, but alpha is 3 beta, so we can substitute alpha by 3 beta, and we get that 2 theta equals to 3 beta plus beta. That is to say 2 theta equals to 4 beta. We divided equation number 1 by 2, and we got that theta equals to 2 beta. Theta equals to 2 beta. So this is angle theta, and this is angle beta. So if theta equals to 2 beta, then this angle must be also equal to beta in order to complete the sum of those two angles to 2 beta, because 2 beta equals to theta. And here also we have angle theta, and according to the equation that theta equals to 2 beta, here theta equals to 2 beta. So this angle equals to angle NPQ equals to 2 beta, and angle NPM also equals to 2 beta. Okay? And we proved that triangle NPS is congruent to triangle PMS. Triangle NPS is congruent to triangle MPS. First of all, it is given us in the question that this angle equals to 45 degrees. But MS is perpendicular to QR. That is to say this angle equals to 90 degrees. This angle equals to 90 degrees, but this angle equals to 45 degrees. So this angle must be equal also to 45 degrees in order to complete the sum of the angles to 90 degrees, because this angle equals to 90 degrees. So those two angles, they are both equal to 45 degrees. And those two angles are also both equal to beta. So we proved that triangle NPS is congruent to triangle PMS. Triangle NPS is congruent to triangle MPS. Why they congruent to each other? First of all, we have angle NPS that equals to angle MPS equals to beta. Those two angles, they are both equal to each other, they are both equal to beta, and we have PS equals to PS. PS equals to itself, it is a common side that belongs to both triangles, and we have those two angles that are both equal to 45 degrees. Angle NSP equals to angle MSP equals to 45 degrees. So we proved the triangle NPS is congruent to triangle PMS according to angle side angle rule. Okay? And from that we will conclude that SM equals to SN. SM equals to SN. Then I drew this triangle MSN again, because it is a right triangle that has two sides that are equal to each other. A right triangle with two sides that are equal to each other. Here, triangle MSN is a right triangle that has two sides that are equal to each other. It is a right triangle with side MS that equals to SN. Because of the fact that MS equals to SN, those two angles must be equal to each other. and this angle is 90 degrees. So the sum of those two angles must be equal to 90 degrees, and they are equal to each other. So if this angle is y, this angle must be also equal to y. That is to say, y plus y must be equal to 90 degrees. We divided this equation by 2, and we got that angle y equals to 45 degrees. So this angle is 45 degrees, and this angle is 45 degrees. Okay, so angle MNS is equal to 45 degrees. This angle MNS is equal to 45 degrees. Okay, then we proved that triangle PQN is congruent to triangle PNM. Triangle PQN is congruent to triangle PMN. Why? Because we have PQ equals to PM. PQ equals to PM because we have those two angles that are equal to each other, they are equal to 2x. Therefore PQ equals to PM. We also know that angle QPN equals to angle MPN equals to 2 beta. This angle equals to 2 beta, and this angle will be also equals to 2 beta. So those two angles are equal to each other, and PN equals to PM here. PN equals to PN. It is a common side that belongs to both triangles. Okay, PN equals to PN. PN equals to PN. Okay, so we actually have two sides, and the angle between them in triangle PQN that equals to two sides, that is to say PN and PM, and the angle between them in triangle NPS. Therefore, those two triangles can go into each other according to side angle side rule. Okay, triangle PQN can go into triangle PMN according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that PN equals to MN. Okay, PN equals to MN. QNM equals to QN. Okay, from the fact that those two triangles can go into each other, we will conclude that MN equals to NQ. Okay, but this angle NQM equals to X. You can see here, angle M here, angle MQN equals to X. Okay, angle QMN equals to X, therefore this angle must be also equal to X. So those two angles are equal to each other because of the fact that those two sides are equal to each other. We have already found out that angle MNS equals to 45 degrees. This angle MNS equals to 45 degrees from one side, but from the other side, angle MNS equals to 2x because it is the exterior angle of triangle MQN, and it equals to the sum of the angles that are not adjacent to this angle. That is to say, it equals to 2x plus x. So from one side, angle MNS equals to 45 degrees. From the other side, angle MNS equals to 2x. So 2x equals to 45 degrees. Therefore, x equals to 45 degrees over 2. So we found out that angle x equals to 22.45. It equals to 22.5 degrees according to the second method. Okay, thank you very much.